All right, so welcome everyone to MapTime Davis. My name is Michelle Tobias. I am the Geospatial Data Specialist at UC Davis Data Lab. And just a quick intro to what all of that means. So Data Lab is a entity that is housed within the UC Davis Library, both physically and within the structure of the library. And we are a data science, organization on campus. We help researchers with all manner of data science things from data collection all the way through analysis, workflow design, and then interpretation and visualization and things like that. And we have weekly office hours where you can come ask for help. And we also partner with faculty and staff on research projects. But we also do educational things like this workshop series for spatial data called MapTime Davis. And MapTime Davis started back in 2017. It's a part of a larger organization called MapTime that has kind of grown into a global meetup organization for folks who want to do spatial data. So our flavor of MapTime is a little bit more research oriented than others, but we have, partner meetups all over the world, including some local ones like San Francisco and Sacramento, but also in most major cities, there's some form of MapTime. So welcome, we're glad you're here. I'll post some links in the chat for our upcoming schedule and for if you want to come to drop-in hours for Data Lab, those links will be there, but you can find all of this information at datalab.ucdavis.edu as well. So now that I've mentioned upcoming things, you might want to take a look at our schedule and see we've got some things coming up, a couple more workshops this quarter. So next week, we're going to have a session on getting started with ArcGIS Online. So if you're interested in learning about that or getting more savvy with ArcGIS Online, Karen Beardsley is going to be our speaker, and she's very familiar with that platform and is a really good person to answer questions. We also have ArcGIS field maps coming up with folks from Esri are going to come teach that. Following that, we've got a session on PostGIS with the Crunchy Data tutorials, which are excellent. I've been through some of them and they are really good. So if you're interested in learning about spatial SQL and databases, the workshop on November 9th is going to be really good. I'm really looking forward to that. And our speaker is an expert in that arena. And then finally, our last workshop of the quarter on November 16th is going to be Intro to Desktop GIS with QGIS. So if you are new to desktop GIS or you want to get more familiar with QGIS, come hang out with me and we will learn some more about that. So with that, it's enough talking for me. I'm going to hand it over to Taylor, who is going to do our workshop today, which is entitled Interactive Maps with R Shiny. I'm super excited for this today, and I know a lot of you are because you've emailed me and told me. So welcome, Taylor. We're glad that you're here.
Hi. Good morning, everyone. I'm Taylor, like Michelle said. I've been coming to these MapTime Davis on and off since I was a grad student here, and now I am an assistant specialist, and I work kind of at the intersection of research and extension with small grains crops. So I'm going to go ahead and post the GitHub in the chat here. Most of these things I'm going to work off of the website on the GitHub. Let me share my screen so everyone can see what I'm seeing. Let's see. Can you guys see that, Michelle?
Yes, looks good.
Okay. So I'm going to be walking through what's on the website here, but if you want to download the whole thing, but also you can kind of just copy and paste most of it straight into R. But I am going to be going through this website that will kind of walk us through it. If you get lost, you can come back to it. Whatever, just a little bit about what's on this GitHub. There's actually in the R version, we're going to create some versions of our Shiny apps that like build on each other. So if you get lost, there should be a version here that you could just open and be where everyone else is in the group. Or if you maybe miscopy and paste something, mistype something, you can go here and look what is the working version of the app as well. So with that, I'm going to start with a little bit of intro, as everyone maybe downloads it or gets their RStudio set up. So feel free to work on that as I talk about this a little bit and show some examples and where we're going. So hopefully you have R in RStudio. We're going to assume a very basic knowledge of those two things. So some of the things might seem crazy and a lot, but please feel free to stop and ask questions in the chat. Michelle and other people on this call can help answer them, and I will try to pause and answer questions as they come as well. And then we'll be starting with the leaflet package, which is open source maps, but then hopefully if we have time can get to the Google way, which uses Google Maps in R, and it uses a very similar syntax and same background Java that you're not going to see, but it works the same in R as the leaflet package. So I think it's kind of self-explanatory why you would want to create an interactive map and why you might want to use our Shiny. So we started doing these interactive maps in our Shiny tools, mainly as a communication device and way to collect pieces of information from our users. We got a grant and have been working on nitrogen management for farmers. And so with that, we are trying to communicate things like soil properties, weather, all sorts of things that are related to their specific field at a specific time. So this, I'm going to show you the one that we created, and we are about to, we've kind of soft launched it, and we're about to launch it fully to growers in California who grow small grains. And this is kind of what I'm going to base today's tutorial off of. If we're going to create a map somewhat like this. So here, it's okay if you don't know anything about agriculture, but we have a map that we start off with, and we ask the farmers to find their field, and they can zoom in, they can move a point to their field, they can search if they want that they have a field in Tule Lake, California. It will move them there as well as the marker, and then they can say, okay, this is my field, this is when I planted my field. You go back to Davis since everyone is a little more. They could click on their field and say, this is when I planted it. So if they planted it sometime last year, and then they went, if you're using last year's data, for example, to maybe apply fertilizer in February, they can choose what type of small grain they planted, whether they irrigate it, and then that point on that map is going to pull them a bunch of data about their field and help them make decisions. So it'll gather the historical and the seasonal data for them, and then they can move on. It gives them an estimate of growth stage. And so really what the Shiny does is uses that spatial data in interaction with a bunch of other data in order to give them that piece of information. There's also things built in here that if, for example, I try to go out of California, if you see down here, it'll give us an error. So we'll create that as well today and make sure the users are within the area that you want them to be in. And then there's different regions that have different behaviors. So this is the main wheat growing region. There's one behavior. If I'm in this region, I don't have a growth model because most wheat's not grown there. So it actually has a different behavior in the app. So hopefully we get through some simple examples of how to create all of those things. Back to the website. Now, that's kind of what's possible. I don't know how familiar everyone is with Shiny. So really, Shiny is our code made to be interactive. So it's a platform built for using interactive applications. There's a lot of free online tutorials and things. It's open source. And most people in the research community have some experience with R. And so that's one of the reasons to use it in the first place. And then with it, there are several parts, and we'll create the functions for each of these parts. But really, there's just an inputs, processes, and then outputs. And so your inputs can be things from the user. It can be data that you are adding to your map, that or other data that's non-spatial. The processes might be some sort of function or calculation. It could be a very simple, just return this lat and long and tell me which region you're in. And then the outputs are what the user is going to see. So those are the basic pieces of it. And then when you're starting an application, that's kind of what you need to think about. What inputs will the user provide and what will they be able to change? What outputs are needed and how are they going to be presented to the user? And then what processes are needed to take those inputs to the outputs. So there's lots of examples online. The link here isn't actually, but if you go to like the RStudio Shiny, they have a gallery of all the different Shiny tools. And as you can see, there's this, the inputs are in what's called the user interface or the UI. Then you have the outputs that are defined right here in the server, and then it puts it together in an app. And for like here, I could say, 300 observations, and it changes, and you can see where it changes here. That's non-spatial data, very simple, but just want everyone to see the different parts to it. And I'll give you the code to those parts for the interactive maps. So there's some good resources here. If anyone else has other resources, feel free to suggest. I just started learning all this stuff a couple years ago and have used just kind of the internet and these resources that are there for you to learn about them. So we're actually going to start with the leaflet because that is the open source and you're not going to need anything. If we have time, we'll get to the Google version of it and do that. But for that, you need an API, and I can share my public API with everyone who's on this call for now, but might cause a little bit of troubleshooting. So if everyone can get to here, I'm going to start showing my RStudio instead of this, but you can still follow along because that's what I'm going to be working off of. Okay, so if you have the GitHub repository downloaded, it should look like this, and you can follow along and actually just download or open each of these apps. But I'm just going to start from scratch, and everyone can work along and build their apps as we go as well. So I'm going to just go ahead and create a new R script here, and we will start from scratch. Okay, so if you haven't already, all of these applications that we're creating are going to need the Shiny package as well as the leaflet package. So I already have those installed, but if you don't have them installed, you can do install.packages and just put it in quotes, Shiny, leaflet, either of those. There's a few other packages we'll use throughout the as we go. If you don't have them, it's the same exact process. You just install packages, and you can do that in your console pretty easily. So we'll get Shiny and we'll get leaflet. Okay. So the first thing we're going to do is just create a base map pretty much. And like I said, there is the inputs and the outputs. And for this, we'll really just want the output of a map. We have to start somewhere pretty much. So first we're going to define the user application, the user side of what the user is going to see. And we want them to see a map. So if we do the UI like this, and then we create a page, and it's going to be called fluid page. We will tweak what this looks like later on, but this is like your very basic shiny, let's create a page and let everything move around in it. And then we can put it in boxes and make it look pretty later. So for leaflet in Shiny, it's actually called leaflet output, and then we'll have to give it an ID. So with any of these Shiny things, you're gonna have to give the item an ID to link the output and the input, so that they know that those are the two things that need to be linked. So in here, we'll put the output ID, and I'm just going to call it map because we have one map here. So that's going to be our entire user interface function for now. And then we'll have to create the server function, which is what's going to happen in R that the user is not going to see, but that we want to run behind the scenes. So a server function, we want to call it server, and it is a function. So it takes inputs and then it'll return outputs. But so we need to give it input and output. And like any function in R, we need the curly braces here in order to put it, to make it a function. So then within this server function, we have to define what this map is. So I'm gonna say I want an output, and then I do a $, and that I would give it the same ID that I named in my user interface ID. And then here I'm going to put render leaflet. So that means we're actually going to render the map. It has a curly brace after that as well. And then we're going to give it leaflet, which is what you would use. This leaflet function is what you would use in R if you just wanted to create a map with leaflet, not in Shiny. But we're going to just jump straight into creating it in Shiny. And then if you do this and we try to run it, it's going to create a blank map. There's absolutely nothing there. You wouldn't even know it was there. So we're going to just go ahead and add some basic tiles. And so the basic tiles here use the OpenStreetMap, but you're just we'll see when we run it. So we have defined our user interface, our server, and then in order to actually run it, we have to use the Shiny app function and tell it my UI is here, my server is in that variable. So right now you could just highlight this all, run it all, and it should open your browser, but we also can save it and then it'll give us an option to run it straight from our console. So let's actually save it. Put it in here. And so you see up here, now that I've actually saved it, it knows that it's a Shiny app because it has all the pieces of a Shiny app. And I can actually press here to run the application. Under the options, you can have it run in the viewer pane, like in your RStudio console, but I would recommend you actually run it in your browser. Some of these things have weird settings and stuff. And if you're actually ever creating this for someone else to use, you'll want to see what it looks like in a browser, in Google Chrome, in Firefox, whatever you use, to see what a user will also see. Okay, so let's press run app. And what you should see in your browser is something like this. We just have the tiles, map, we have some zoom control, it's built in. You can see this is leaflet open source map tiles, but that's all we have so far. But at the very basics, we have created a Shiny app and we have a map on it. Not a super interesting map, but it is a map. So we're going to build on from here and add pieces to our map and functions to it as well. Stop me if there are any questions, please. Okay. So I'm gonna, if you see down here in the console, it's still running and listening to the map. So you can just press stop and it will stop running that map. If you had it open in your browser still, it would just disconnect and you wouldn't see it anymore. So now we want to think about, go ahead, is there a question?
Yeah, I had a question. So this was the default map that's there inside Leaflet, right? So supposing we had a specific map that we wanted to upload. So in the output ID, can we give a URL or can we give a JPEG map file, or what should we be defining for a user defined map?
Yeah, so there's, and then next step we'll add different tiles. You can add tiles from a URL or from other providers, like Esri has, the one I'm going to show is Esri's background tiles. Or if you have like, depending on what your user defined map is, if it's just like a polygon or points on a map, you can add those to overlay onto the OpenStreetMap or someone else's tiles.
Gotcha.
Does that make sense?
Yep. Thanks, Taylor.
Okay, so yeah, so now we want to think about what options we want for our base map. We've added these tiles, but we can, it's looking at the whole world. If we want to say center it and look at Davis, California, we can set the view of the map to be centered somewhere and also zoom it into a certain perspective. So from that, I'm just going to go in here and say set view. And then I want to give it a latitude and a longitude. And I am just going to copy the ones for Davis. You guys are following along, or I can put it in here in the chat so that we don't have to type it out. Doesn't have to be that exact, but, and then set the zoom. And you can play with what kind of zoom you might want. And I'm going to then make sure I pipe to the add tiles so that once I set the view, I still am adding my tiles. I'm gonna add a note in here that we're going to center the map. Davis, California. It's always good to add lots of notes as you're creating things, because as the applications get bigger and bigger, they're not usually on just one file. We start having multiple files of, you know, the UI is in one file, the server's in one file, there's functions in a different file. So the more you can take notes for yourself and for other people who are going to be using it, the better. So here's one. And then let's say we want to add tiles that aren't the OpenStreetMap tiles. I will just go here and we're going to add provider tile. You see it pops up here. And I'm going to add the Esri world imagery. So that would be something that looks like a satellite imagery of the world that Esri has. And then I am going to just get rid of this OpenStreetMap tile, but we can leave it in there if you want. You can delete it or just use the hash to make it not run. So these are some options that are pretty easy to change. There's a bunch of different providers with different tiles. You can add a URL in the provider tiles. If you have a specific one, this is where you would put your background imagery here. So if you run this app now, you should be making some progress. You can see here's California, and it's a satellite imagery. We're a little bit zoomed in. So you can zoom back out, and zoom back in. We are centered right here in Davis. if we get to the Google version of it, you can actually toggle between the different views right in Google, which is one of the things I like about it. But so we've added our background. That's great. Still not super interesting. If you have your own data, your own map that you want to create, that's really what we want to show and we want the user to interact with. So let's add some data to this map. If you have the GitHub or if you download anything, in the data folder is probably the one piece you're really going to need is this California ag regions shapefile and the files associated with it. And so in here, this is a polygon. It has just two types of regions, somewhat like the example I was showing earlier. There is one that is an ag region and one that is a non-defined region, rest of California. And that's just places that have had agricultural production in the past 10 years in California. And so we use that a lot and we'll use it here. So I am going to go ahead and define some global variables that will be used throughout the application. So if you were creating a multi-file application, you could put these in a different file, but we're going to put them in the same file for ease of access. So we'll just call this the shapefile. And then there's many ways to read in a shapefile. I'm just going to use the SF package here. If you have a different way that you want to do it, it should still work. And read it in, and from here, it's in the data folder. Like that. So if I tried to run that now, it's not going to be in the same working directory. If I ran this now, it's going to tell me it doesn't exist because my working directory isn't the same as where this application's working directory is. But this is the application's working directory is actually starting where I have the application saved. So I have to make sure I'm putting any files relative to my application. So I have to go up a folder and then into the data folder to read this. And so when I press run app, it will be able to read that file. So then from here, I'm going to add some different colors that I want on my map. Since I have these two regions, I want to show them in a different color. Copy and paste this just so it's a lot to type, but I'll go through it. So here, making sure it's an actual using this package, if you read it in a different way, we can actually use the dplyr to mutate it. I think you're going to need to add the dplyr package. Don't already have it loaded. I typically just always have it loaded, so sometimes miss that. But in order to mutate, we're going to pretty much add a column in the data of this file and say if it's not an NA, meaning it's part of the not defined region, we'll actually make it transparent so people can see through to the background map. And if not, we'll give it kind of a grayed out color since we're not as interested in that area. But you could put any color you wanted here. You could make it magenta, you could, anything you wanted. If you had a different shapefile or a different piece of data, you could color it by what kind of data is in your file as well. So then in order to add this file that we've just read in and colored, we have to actually add it to our map. So we have our background here, and then what I'm going to do here is add polygons. And so we have to give our polygons their outline color, their in color. There's a bunch of different options. But let's give them an outline color of black, and then their fill color, which we defined above in this way. Then we can just say, I want it to be the little squiggly and call it fill color, which is what we call this variable up here, so that it will color it those colors that we already defined. And then I don't want it to be completely solid. I still want people to be able to see the background, so I can change something like the fill opacity, and I'm going to give it a 0.5. Now I am missing one critical piece of information here. I don't have the actual data file in my server. So here you put it within the actual leaflet call, and then it will add the polygons and the colors in the add polygons function. So if you have all of these pieces, you've read it in, you've added it to your leaflet call, and then you do the add polygons with what colors and things you want. Save the app and we run it. We should be able to visualize that shapefile on our map. Now you can see on the server side, it's telling me that we've got the, it's reading the packages, and then here is the data source. It's different things. So then if I pull my browser over here, this is what the data file looks like. So anything that's not an agricultural region is kind of grayed out, but everything that is transparent, but it is all one polygon. So it's somewhat of a simple data set, just two types of regions, but you can layer on and add many different pieces there. Okay. So we're still, people can view this, but we're not really giving them interaction yet. And so like I showed in the example that we use, our main point of interaction typically is that users can move the point around, and then we use that point to extract data from the polygon data or from just like their lat long, and then pull data from other data sources and databases. So let's add a point that the users can move around on the map. And so we'll keep this app that we already have, and then we're just going to add a marker. So here we'll do the pipe and do add markers. So here I am just going to actually put it at the same place that we are already centered at. Alex, did you have something to add?
Oh, there was a question in the chat about
Okay.
why it's requiring the Google Way package right now.
Shouldn't be, unless they're on a set. Let me look at the chat.
I mean, it did it to me too.
Oh, it did it to you too.
I assumed that it happened when the set view came in, and I assumed that somewhere in Shiny or Leaflet's implementation, it thinks it needs that package as a dependency, even if it's not using it yet.
Interesting. Yeah, because it doesn't actually like load it for me or ever ask me for it. Even like I started a new R session, but I do have it installed, and usually it'll ask you for your API key if you're trying to use the Google Way package.
Yeah,
So,
it's possible that one of the packages just has a check to see if it's installed.
Mhm.
And if it's not, then it might prompt.
yeah. So yeah, a lot of these things have a lot of other dependency packages.
My advice to people is if it tells you you need a package, just install it.
Yeah. I think I use it every day, and it just kind of like you eventually get all the packages that you would run into and you would need, but it's kind of like this interwoven universe of things that someone builds off of something else someone else made. So I could see it being very likely it would need that. But you might as well download the Google Wave package, and if we get to that, we can actually show you how to use it too. So, but back to the markers, I'm going to add the markers at the same place where already centered our map. So I can just copy from up here and put that down here. And then there's a lot of options on the markers, like what do I want the marker to look like? What kind of features do I want the marker to have? The one thing I want the marker to be able to do is for the user to be able to drag it. That's the most important piece to me. So I'm going to say options and marker options. And then within here, you see there's a bunch of things. Is it clickable? Is it interactive? Is it draggable? But we're just going to say it's draggable and say true, so that someone could actually move their marker around. I'm going to stop the old app running, save this, and then run this with the marker. All we've done is added one marker to the application. And see, we have a single marker here. You can move it around. It doesn't really tell us anything yet, but it is there. And the next step is that we're going to make that marker tell us something. So we have all the pieces. Go ahead, Alex.
Oh, we just had another question pop up, which I think you might be able to answer. And it's someone still has OpenStreetMap showing up even though they added Esri World imagery.
I'm guessing the most common mistake there is that you didn't actually turn off the OpenStreetMap potentially. So that if you're asking it for multiple tiles, it's going to just overwrite the previous one. Whichever one you have last is what's going to show up first. Okay.
I also discovered that you have to make sure to stop a running server before you try to run it again. Otherwise, it doesn't necessarily refresh.
Yes. Yeah. So yeah, it's very easy to just close your browser. But if you see like in RStudio here in the console, it thinks it's still running. So you actually have to press stop in order to stop it and then rerun it. So I'm getting an error, cannot open. If you are running it just by running like their Shiny app and not pressing run app, it won't know where that file is correctly. Or maybe you saved it in a different spot. It's a hard one of all of these things of where did you save your file and how to find it again. It's kind of unique to your thing.
So I downloaded like the whole thing from your GitHub.
Okay.
And so like I made sure that the path is correct. And I like checked my working directory and it looks like it's at the interactive maps in our Shiny main. So I'm not too sure. I'm kind of stuck here now.
Okay. So the one thing you can do here is if you go to the R version here and just open, we're on, where are we? Probably should have labeled them a little more descriptively.
I think you're on 4.
I think I'm on step 4. Yeah. So if you go to 4 and open that and just press run, we should get the exact thing that we just have created step by step. So maybe there's something wrong and you could just start from 4.
Yeah, so that seemed to work. Thank you.
Okay, perfect. Back up here is very helpful for anyone who wants to try to do something like this. Okay, so our map is not fully interactive because we're not actually collecting or giving any feedback for the user. And that's really what we want. So when I'm creating an interactive piece for the user, I want to make sure I think about what the typical user's behavior is going to be, the instructions they might need in order to actually get them to give me the inputs that I want. So in the maps that we've created, the user can drag the marker, but what happens if the user clicks on the map? Do we want them to be able to click on the map? What kind of information would we want for them to have if they click on the map? In more complicated applications, in some of the ones we've created, we use the user's geolocation. So if they're in their field, like on their phone, it actually just puts the pin at their geolocation. And they really like that piece of information. And then in some of the other functions, you can actually like search like you would in Google Maps. Like I showed, you could search the city you're in. How is your map going to respond to that? So you want to think about kind of those things before we start adding them. But let's say we want to give the user two things. We want them to be able to drag that marker, and we want them to be able to click on the map and actually receive feedback. So the way we do this in Shiny is by observing these interactive events. And so you can do things, you can observe specific events, or you can observe variables that are going to change. And so the first thing we're going to do is just observe the events. And so within the server, we've created our map, and that is one piece. And now we're going to create another piece that is observe in caps lock event. And so we have to give this an input of what are we going to observe. And so it's taking these inputs from the input that we gave it, and we're going to say what we want. We want to look at the map, which that's the ID of our map. So if your map was called something different than map, it would have to be, you know, my map or map one or whatever you called it. And then we're going to look at the marker. And then the action that we're observing is called the drag end. So we want to see where they ended when they dragged it. This is called something a little bit different in every iteration of these interactive Shiny maps, but this is what it's called in Leaflet. So it's something you can look up in the documentation. And all I'm going to do to start off with is just print what this input is. And so it shows up in my R console. The user's not going to see it yet, but I want to actually just observe it and look at the input of the map marker. Okay. And then maybe I also want to see if the user clicked something, so I can do the same thing and observe a click, just to see what kind of information I'm going to get as the creator on the server side that the user is going to give me. So I'm going to click on the map. They're going to click on the shape, which does limit somewhat that they have to click on the shape. So if they clicked outside of the shape, somewhere that's not within our defines of California, it's not going to return anything in this case. And then the shape is what it's called here in the leaflet package, but it's also called like polygon or some other things in some of the other package. So that's also something that would change if you're using a different package. So I'm going to print actually what I want to know, just because I don't want to be overwhelmed with information, and you probably don't want to, because there's actually a lot of information if they click on something. I just want to know the latitude that they click, and then I'm going to also know the longitude that they click. If you try to look at all the information, you'll just prints out a lot of information that you may or may not use. At least for now, we're not going to use. So that's what we want to look at right now, just what happens when they do that. So let's save it. We don't have a running server, and let's run that again. So the map itself should look exactly the same as it did before, but I'm going to, if you watch my console here, I'm going to drag, and now you see where the information about dragging. If I click over here, it's going to print the latitude and longitude. Maybe I can actually show both. If I drag, it gives me that. I drag over here, it gives me that. I click. The clicking doesn't actually move my marker, but it is returning pieces of information. So that's a good thing to note as we're moving forward. And so that's kind of our first piece of interactivity. So now we really want the user to see some of this information, and that information to actually maybe go through a process to tell them, okay, are you in an agricultural region, or what's the rainfall, or whatever you're trying to calculate for them. So close that, stop our app, and actually show the user this information. So in order to show the user any piece of information, we have to create a place for it on the user interface, as well as actually render that in the server function. So first of all, in the user interface, right now we only have a map, but I'm going to put a comma and then say I want a text output. We're just going to name it, give it an ID of text. You give it an ID of something else if you want. There's a bunch of different types of outputs. Like you can put HTML, or you can put this. This is the simplest one, so we're just going to start here and we'll make it look nice later. And then just like we have observed these pieces, then let's create the output, just like we did for the map. But this one, we have the ID of text, and we are going to render not a map, but text. And still need the curly braces in here. And then what piece of text do we want to show them? Let's just show them the input of the map shape click. And we're just going to look at the latitude. So that's one of the things we were printing. And this is kind of like just a test for us of, okay, can we show that piece of information we were seeing in the console to the user on the user interface? Okay, so if we run that again, look at the user interface. Right now, I see nothing, right? But if you remember what we actually said, we said the input of the map shape click. So it's not going to show the user anything until we click on something. So if we click over here, you notice, oh, it's actually putting a piece of text down here. And every time I click in a different spot, it's going to change it to the latitude that we're clicking on. Not the prettiest, but technically it's interactive and we're returning something to the user. So that's first step. We have somewhat of all the pieces of like, okay, we can allow the user to change things and we're returning them a piece of information. So to me, that's like you've achieved 90% of it. And now we got to go through the whole, let's make the application user friendly, because with any of these things, the goal is for the users to better understand the information and actually be able to use the application. So this isn't super user friendly at the moment, and it's not really communicating what we want to communicate. Okay. So to me, I may have the list up on here of the things that should be added. We should add explanation or some instructions to the user. We should limit the things the user can and cannot change. Like they can drag their marker outside of California, but they're not going to actually receive information about things. The app should have somewhat consistent behavior. Like if you click on one thing, we should still receive the same piece of information. Like I said at the beginning, we probably want to give the user an error if they do something wrong. And then we just want to make it as easy to see and understand as possible. So we're going to have to add a few special shiny things in here in order to make that possible. So we're going to first use a reactive value to update the map. So just like we had these observe certain input events, We can also observe reactive values or variables we create. And so we're going to create a reactive value of these, of the marker. So let's create one right here. And I'm going to call it where the current markers are. So, and that is a reactive values. So this is a special type of variable in Shiny that we can actually change with multiple different events. So if we click on the map, we can change the reactive value of the current marker. If we drag on the map, we can still also change the same thing. If we create it as a non-reactive value, it would be like a set variable, and Shiny would not like it and give you a lot of errors. So we want to make it sure it's reactive. Now I'm going to give it the exact same starting spot as we have been giving everything else, just to be consistent. If we're I'm just going to follow my own code, and that's called LON instead of LNG in on the GitHub. So make sure if we're following that, I'll just keep with that. So now we have a reactive variable here, and then we can use these same observe event functions to actually update that variable. So instead of just printing it when we drag it, we could say we want the current marker's latitude to become wherever the input user ends up dragging their point. We just want the latitude. We don't want to print everything else. And the same thing for the longitude of that current marker. And this one is called LN, and this one is called LN. But that's okay. So we would actually change these values to whatever the user dragged them to. I'm trying to achieve here is like we're going to actually change the current markers, but we want to actually change the marker so that if someone clicks on the map, the marker moves as well. So if we want to do that, we are going to actually clear the marker and move it. So under our map shape click, we are going to then say, we're going to use something called the leaflet proxy, which is pretty much like render leaflet, but it's a, we already created the map, and then this is kind of like a mirror of it. So we're going to give it the same exact ID because we're using the same exact base map and all the information we already gave it, but we just kind of want to update that map. So we're going to clear the markers. If someone clicks on the on our shape somewhere, we're going to clear the markers, and then we're going to add new markers where that person actually clicked. So add markers, and it's going to be the data frame of the latitude will be wherever we actually have that click, map shape click latitude. Comma. Longitude will be the same. Just copy this, typing it all out and making a typo. There we go. And this new marker I created, I still want to give the same options as I did before. So if I wanted different options, if I wanted to change color or whatever, I could do that. But I'm going to say I want it to look the same, act the same. I just want it to be the default, and I want it to be draggable. And then the one thing we haven't done here is if the user clicks, it's gonna clear a marker, it's gonna create a new marker, but our current marker reactive value is not that. So we want to actually do the same thing and make sure our current marker, which is maybe what we're going to output to the user eventually, is the map marker click. So now if they drag it or if they click on it, the marker is going to move, and we'll update this variable internally that's our current marker and have it be the same coordinates of where the marker is. So let's save that and take a look and make sure it works. Need for leaflet proxy. My understanding is that it's so we don't have to recreate the map entirely. Like we could recreate and regenerate the map, but it's going to take a long time versus if we just use this, it's already going to use what we already have loaded, and just update what we already have. I'm not sure that's the best explanation. If someone has a more technical one. But here, so we can drag it still, but also if we click, oh, I have typed something wrong. Let's go back. It shouldn't give us this. So leaflet proxy, clear markers. Thanks, Michelle, for that. It's true. Line 50. Not sure. Here, I was copy and paste. Already have it written out. There we go. I'll try it again. Hopefully everyone did make the same typo I did. Live coding can always catch you up, I think. Okay. Not sure, is it working for other people? Or are we missing a piece here? Hopefully it's working for them. If it's not working, we can also open app 7 because it has all the pieces in it. I'll just double check this. All of that out. One more time. Okay. Well, I'm going to work off this. I'm not sure exactly what I've done. If anyone knows where we've made a mistake, please let me know. Someone said line 50, but I'm not exactly sure what went wrong in line 50. So I'm going to keep going. Because if you go to app 7, you run app 7. And see where we are going. is this, and should be able to click and it moves, or drag and move. So, and give the user the information here. So let's go through like how to actually create this. Somewhere we made a small mistake and we're getting stuck. So if you open app 7, or if yours is working, the next thing I added here was defined a function that's going to tell us whether our point is over an agricultural region or it's not over an agricultural region. So we're going to do, this is the function right here, and it's also in the global environment, just like the shapefile data is. So this function is going to use the shapefile and the markers to tell us whether those markers, where they are in our data set. So if you have a different data set and you want to say, what county are we in or something, you could return something like that with the same thing. So what I'm doing is remove the notification if we gave the user an error, which I'll show you in a second. And then we'll add the data frame of the markers, and then we're going to return if it's over the thing. You might just want to copy and paste this. It's pretty much if the point intersects where the shapefile, and then we're going to return the information from that intersection. And then this error, the region error, remove notification, we actually want to add that so that the user will get an error if something happens. So in our server function, we're observing its drag, and we're going to use that function right here. And we have our shapefile, and we're going to create our markers to be where the user dragged it. And then if there's no data being returned because they dragged it outside of where our data is, then we're going to show the users this error, and it'll pop up as a little error in the corner of their screen and say there's no data for this location, and it will move, and we're going to move the point back. And that's just us telling them that. But if there is not an error and there actually is data, then we're going to update our reactive variable of the current markers. So just like we did before, we'll update those, and then we're going to clear and add the markers back to the map. Okay. Someone went back here and said it might be because I had something backwards. Flat and long reversed. Might be. 160. Current markers, long and flat. That's probably it. It is very picky about some things like that. So we can try that. Sometimes you think you have it all right, but then it's just like one little thing that doesn't work. 2331. Should have named that the same thing. See if all the guys paying much closer attention to details. Let's see if that fixes it.
So Leah's pointing out in the chat that sometimes in your variable, you call it lawn and sometimes it's LNG. So that could be potentially what's causing it too.
Yeah,
If they're called different things.
I'm guessing that probably is the case. It should all.
It's
We
so
should just-
easy to do.
should just call it all the same thing. The default of what it's called in the different versions of things is different though. So it's a very easy mistake that obviously I made because the map shape click, it's actually called LNG in the leaflet package, but it's LON in some of the other shiny stuff. So
That's
Yeah.
true across the whole geospatial world. No one has decided what we're calling these as a standard. So I think it's a good lesson for everyone to learn to pay attention to what the variable names need to be for the different parameters.
yes, so I'm sure you could dig in and find I messed it up somewhere in here, but if you go to app 7, it is correct because it's working there. And we'll keep working off that for now. Okay, so we updated the map, we checked that the marker is within the defined area, and then it updates for them. And then we want to make sure the only other thing that's different in the final kind of app of app 7 that I showed you is that we actually render the text so it looks nice for the user. So instead of just saying render text, I actually paste some things together that say, okay, here's the current marker latitude, and we're going to call it current markers lat and current marker longitude. And then I'll say, if it's in the region, is it in an agricultural region or is it not in an agricultural region? And return that to the user rather than just that little, moving latitude that we had at the bottom. And then in this UI part, I've changed it so that we have the different boxes and show you. So before we just had the map all the way across the top, and it was putting the latitude at the bottom. But if we use something like Shiny Dashboard, which I've loaded up here in the library, then it kind of creates a default layout for us that is more user-friendly. And we can create a header, we could create a sidebar with multiple tabs so that users could go and look at different pieces of data or maps. And then we have things we can add like boxes and outputs. So if you want to make it more user-friendly and have it look like that, then that is what I've done here, so that we actually have some instructions for the user and tell them to click or drag it. And then we return that. So we should be able to, with this one, click, drag. And if we drag it outside of California, you see there's an error down here and it moves it back here. So that's what we're looking for. I will a lot of good ideas about how to fix the problem from before. Are there any questions about how this app 7 works, since we didn't totally add all those last user-friendly pieces? If not, I'll show you how to use the Google package. It's very similar, so hopefully we get it right. But because we already done it once, and we'll be definitely more careful.
So there was one question, which is, do you have to drag the marker, or can you click in a new location? Is that supposed to also work?
In this final, by default, that's not what happens, but we created that function that allows it to happen. So if you do click, the marker will move. It's a little slow, but it will move.
Okay, so someone's having a problem with the click working, but the drag is fine. So there's probably a missed line somewhere related.
Yeah, because if the drag is like a default option here, so it doesn't necessarily update anything, but when we're clicking it, what we're actually doing is re-rendering that marker. We're saying clear the other marker, make a new marker where the user has clicked the map. Because to me, that's how the users actually would interact with the map, and people are trying to click on their field and not getting a response they want. And so that's what we've created with a lot of our maps, so that people can click on it and it acts the same way as the marker. So where that's happening, just so make sure it's clear, is when there's a map shape click, we actually use that leaflet proxy, clear the markers, and then add markers again that are from the map shape click, and make them look exactly the same and behave exactly the same. So to the user, it appears like it's the same marker, but what actually happened is that marker got wiped and we created a new marker. Okay. So if we are somewhat good with that, I'm gonna show the same thing in the Google package. So you can practice doing it again and in a very, very similar way. And it uses LON instead of LNG, so everything's consistent and hopefully we won't mess it up. The one thing everyone is going to need is an API key. And so you can make a free account and you get $200 of free calls to the Google server per month, which is like, I use like cents of this. We have like an actual production one for our applications that are public, but in general, it's for your own use, you use very little, and that $200 is plenty. So I'm going to copy it, my key, and throw it in the chat. I will regenerate it and it won't be usable after this after map time, but feel free to like make your own and try it again. But you will need this API key or your own API key in order to actually see a Google map show up when we're doing the next step. So if you are following along on the GitHub, this is like number 2, create your interactive maps with Google Way. And it is exactly the same as what we just did, but we're going to use this other package and show kind of some of the differences and hopefully get a little more practice. So the best place to probably start is to open O2 app 1. And the one thing you're going to do here is it's not on the GitHub, just so we keep it kind of secret of what my code is, and it won't work after today, so it doesn't really matter. But if you want to paste that code as well as, or your code into that map key character vector, it will read that and then be able to use it going forward. So the differences on this very basic, like we're starting out creating a base map, we're just using this, going to use a Google base map instead of the leaflet base map, is that instead of the leaflet output, it's Google_map output. You need the API key, and then you render a Google map with the Google_map. And you're always going to have to give that Google map the key, and you can see it's equals the API key. I could just copy this and paste it in here, but if I needed to use it in other places, it's best to have it as a global variable. So if everyone has done that and you run it, this is where I make sure the API key works for everyone. The default for the Google map is to show up in Melbourne, Australia. And so you should see something like this. Looks kind of like what our base map of the leaflet map, just a tile. And There are some more default settings and options here that Leaflet doesn't have that you can toggle between the satellite and Google Map pretty easily. You can look at like terrain, and so you can easily flip back and forth. The Google Maps, you can also do like routes and stuff. I have more experience with it, so I could probably answer more questions, but it's meant for more like large scale applications. You got Street View if you want. You can make it full screen, and I can see the whole full screen. And then again, we have the zoom in, zoom out. So is that API key working for people? Can everyone create a Google map, or anyone who's trying? Okay, cool, perfect. A little worried about that, but okay. So there are many options, just like there was with our the leaflet maps of where we want to center it, what the zoom level should be, and then what kind of controls we want to give the user. Should we even want them to see that street view or not? Like that might be super confusing for our purposes. So in the Google Map function right here, I am going to go ahead and give it these options. So I want the location, just like I had before, to be Davis. So let's see, 38. Let's try to type everything so it'll be nice and slow and we follow along. So here's my center. I can set the zoom level. We'll set it the same. It's somewhat standardized, but a little bit different in each app or each package. So you'll want to play around with what you want. Some of these are defaults, but it's always good to write out your defaults if you know what you want in case something changes in the app. We've had, the app creators actually update their apps, or not the app creator, the Google Maps creators update it very frequently, as do the Google Way package creators. So a lot of these things change, and the more that you write out, the more stable it's going to be. So something like zoom control right now is a default, but wasn't always a default. So we want to say true, we always want to give the user zoom control. We can say we want the search box. The API key I gave you is not, your search box is not going to work unless you actually connect it to, more things. So let's just remove the search box. And then I don't really want street view control. I will turn that off. And then I can set a width and a height of my map as well. And we're going to just say we want it to be full width at 100%. And I would recommend a lot of these shiny things. You can set the width and height in pixels, or you can also set it in percentages of the user's screen. And if you are expecting a user to look at your map on a different sized thing like a tablet or a phone, would definitely use the percentages. Nice, and you can add different layers in Leaflet. So I definitely use this Google package more than Leaflet, but the Leaflet is completely open source, so that's really nice. So if we do this and we added our defaults to the map, I'm just going to run it right off here and that over, and we are centered in Davis, California again. And we removed our search function, and we don't have that street view option anymore for the user. If you want to generate your own API key, the link is at the top of this page on GitHub. Let's see, copy link address. There you go. If you have a Google account, like I've used my campus account even, and it'll just keep working until you hit $200, and then it'll say, give me a credit card, and you can't actually do anything until next month. But it was pretty straightforward. So we have our base map. We made it our options. So let's add data to the map just like we did before. We're going to also need the dplyr package. And we're going to read in the shapefile just like we did before. So I will copy and paste that part because it is exactly the same. We have the same exact data. We're just going to show it in this version of the map versus the leaflet map. So here we have our Google map, and then the way that it's done in this package is you say add polygons, and then we say give it the data, and the data is going to be our shapefile, and we want our fill color to be what we called fill color as a variable up here on line 8 when we created it. And then we have to give it a stroke color as well. I mean, you don't have to, there are defaults, but I think the default's some crazy color. But you want the outline of your shape to be something, that's what the stroke color is. You can see why I make mistakes, it's because I cannot spell. O3. I'm going to set that stroke color to, and then I'm going to say update map view false. I still want my map view to be centered at this location. I don't want it to update when I add these polygons. Like I would like the previous thing that I specified to still be true. So if I do that, we should now have our polygon the dot and slash on there. I think this is the problem that some people were coming up with earlier. If you didn't specify your file path correctly, do that. We actually read our file, and there we go. We have a black outline. We have this gray area of the non-agricultural regions and a clear area for all the agricultural regions, just like we did before. We zoom all the way out. We have whole state of California. Okay, so just like before, we want to add a marker or a point to the map. Let's stop this server and add a point. So if we, after add polygons, we're going to do a pipe and we say add markers, then our data is actually going to be a data frame. And so here you could upload a CSV file or some other type of file with a bunch of different points if you wanted. And I've had maps that have done that before so that maybe the users can't move them, but I want to show the locations of where all these different things happen. Like here you could say, read a CSV file and it has lat and long in it, and then it would put markers at all of those locations. But we are going to say we want our lat to be 38. And if you notice, the default here is LON instead of LNG, and that is just for this package what they use. So before you start using a new package, always read the documentation, but it's easily confused. So we are also going to make this one draggable. We wanted to have that same behavior, but we also don't want to update the map view whenever the user drags it to be centered on that. So I'm going to say update map view is false. Some chats.
I think the most important question was about bringing in data. Like, can you bring in CSVs of points and use them in the maps in Leaflet or Google?
Yep, you can do that in either one. I guess I didn't mention it previously. but yeah, you could bring in data and add markers for all the data in either of those packages. It starts getting tricky if you want to do something like actually drag them around. It would be like more of a static thing, but you can create something where you just can move all the points around or multiple points and have those points be different colors and have different IDs. There are like kind of endless options there, but you can definitely upload data of the marker type as well. Okay, so we have our marker. If I run this app, I should have a marker on it. And here's my nice marker. And you can see it's draggable, it's not clickable, it has the same default behavior as the marker in the leaflet package. They use the same libraries that underneath. So it's just how they're being used in R is a little bit different. Argument map is missing, no default. I am not sure what that error is. If you don't actually pipe your map to each of these things, you have to give the add polygons. Its first argument is the map itself. And when you're doing the pipe, it's actually passing the information from the map to the add polygons to the markers. So that is a possibility that maybe you're missing one of those pipes. Okay, perfect. Okay, so we want to do the same things that we did before. We want to observe the markers drag and click. So within our server function, we are going to observe event and say the input, and this one is called map marker, and it's just drag. So there's a difference there, and we'll print the input of the map marker drag, just like we did before. And then if we want to look at the click, it's called map polygon click rather than the map shape click, but we can also observe that clicking and say our input map polygon click. Curly brace, and then let's just print the input map polygon click, and let's just look at the latitude for time's sake. Okay, so we should get like we did before if we run this and we watch the console here. Have our points. I'm gonna drag it. I get all this information, and I can see like I might want to use these other pieces of information. I'm not sure what for, but you could. And then if I click, it's just going to return the latitude, is that's the only piece I asked for. But you can see what all information is available there. Let's stop that. So far, so good. It's working. So we're going to then start returning things to the user. Let's see. So under the UI, we're going to add the text output and give it the ID text. And this is going to be the same as before. We'll create an output and make this text and then render text. But map polygon underscore click, and we're going to print that latitude for the user. And I'm missing a curly brace here. There we go. And we should get now that same behavior where we will print the latitude on click for the user. Right down here in the corner. Let's see. Generate time series maps. I'd say like I'll probably try to get through as much as I can in the next like 10-15 minutes, and then I could, if anyone has questions or discussions at the end, we can discuss, and I can try to point people towards some resources, but I don't know that I've done much of that. Okay, so we're outputting things for the user now, and now we're going to get to the point where we want to make our current markers and our reactive values. So let's add those in here. Current markers, and we're going to make a reactive values. So we'll be extra careful here. It's going to be a latitude, and we're going to put it in the same place. And then we're going to give it a longitude with an LON. Okay. Save it. And then we'll use, like we did before, within our observe event functions, we'll use that to update the reactive values. And so in here, we're going to say not print it anymore and just say the current markers. We want the latitude to be equal to the input that the user does, the map marker drag. And then we're going to grab the latitude from that drag. And then the same thing for the longitude. Current markers, longitude, and we'll call the input of where the user dragged that. And then for the click, since it's not a default setting here, we actually have to do the thing where we update the map, clear the markers, and re-add the markers. So in this package, it's also called, we don't create a proxy like we did in Leaflet, but it actually acts a very similar way. We do Google Map update, and we're going to give it our map ID of what map we want to update. We only have one map, and it's called map. And then we'll pipe it and do the next function, which we want to first clear the markers that we have, which is in this case just our one marker. And then we're going to create new markers where the user clicked. So add markers, and we're going to add that, the data for that. So maybe if you uploaded data, now you let the user change that data, but we're going to just create this new data from where the user moved that marker. So data frame, latitude is going to be the input of the map polygon click latitude, and the longitude is going to equal, same mistakes before, of where the user clicked on the polygon. Remember, if you called your map something other than map, it wouldn't be map polygon click. It would be whatever the name of your actual map is. So here we're going to set that. We want these ones to be draggable like they were before, and I don't want to update the map view to center around them. But I do want to output these pieces of information into my reactive value. So I'm going to say current markers, the latitude to this clicked value. Input map. Click. And then the same thing for the longitude. see if this works. So we press run app here. We should be able to click and it move it as well. So that was the, we had a typo less in the last one, but I find this one to be actually much more reactive for some reason and faster, even though it's the same exact code, it's just a different package. Okay, so we're moving our marker around. We can still do weird things like drag it outside of the state of California. And so we want to prevent that like we did last time. And so we can use that same function. And since it's working, let's maybe step through how we created that function a little bit more. So I'm going to create this function called region data. And it's a function in R, just like anything else. And it's going to take two things, the shapefile and the markers, or marker in this case. And from here, we're going to remove any notifications, which if we want to, we know we want to pop up that error, we have to tell it the ID of that notification, which we'll set when we set what that error is. So we want region error is going to be my ID. And then this is, the session is kind of whatever that your domain is that you're working in, kind of like your working directory of Shiny. So I can say I just want to get the default reactive domain. If you had a more complicated app, you could actually set a different session for different things. But that's what that piece of that is, somewhat like the get working directory in regular R. So we're going to set our data frame or this dat variable to be a data frame. And whatever we feed in as markers, we're going to give them a longitude is equals the markers long, and our latitude is equals the markers flat. So then when we do feed markers in there, they have to have a longitude and a latitude on them, or else it won't work. And we'll give this the names, and that's going to just be point. So maybe it gets fed in as something, as a type we don't want, and we want to make sure it's the same type that we are assuming it is. So we'll make sure it's part of the SF package. Give it that, what we just created, that dat variable, and we'll say that the coordinates of that are coming from these things that we called longitude and latitude. And in order for us to be able to tell whether a point overlays our shapefile, just kind of like in any GIS, we have to make sure they have the same coordinate reference system. So just to make sure that that's happening, we're going to set the coordinate reference system, which CRS stands for coordinate reference system, of whatever that point is. And it's going to be the same as what our shapefile is by default, because that's what's in our app. So you're creating a different application like this, you'd want to make sure your coordinate reference systems of what, if the user is inputting data and you already have data there, that they actually match up as always. So those are the different point parts here. And then what we want to return, I'm going to copy again, so I don't have to type it out because I will make a mistake on that long line. But we have the same exact coordinate reference system, and then we can run this intersect function, which is what the core of this is. We want to return of whether the data frame, the data point overlaps the shapefile and what data is in that section that it overlaps. Okay, so now hopefully understand what that region data function is doing a little more. And then we want to use it in our, when we drag outside of of California. So if we want to use that function when the user drags, we're gonna go here and make a variable. I'm calling it RD. We'll use our region data function we just created. It takes the shapefile, and our shapefile is conveniently called shapefile. And it takes markers, right? And the markers that we have here are based on what the user dragged to. So we're gonna do data frame. And the latitude is the input where the map marker drag latitude. And then the longitude is the input where the user dragged there. Okay. So then, just like we did before, we'll want to return an error if this returns no data, or we want to, and then update the map so that it moves back to where it was before. So I will just copy that because we're running a little short on time here, and just throw that in here. So this is the same as before. We update, it's draggable, stuff like that. I think from here, most of it is the same. I'll show you the main pieces of what is different. What O2 app 7, which is the Google Way kind of final app, looks like. Run that here and see what it looks like. And then maybe use the last 10-15 minutes if anyone has any questions about material or other things. Let's try it again. I am not loading Google Maps correctly. Well, you should have a Google Map here and it should do this, but that is pretty much all the material. It does the same thing as before. Does anyone have questions, thing they want to discuss?
So I just want to say thank you, Taylor, for this. This is super awesome, and it's great to see two different ways to do this. What I'd like to do is we'll go ahead and stop the recording, and then we can have a discussion so folks can feel free to ask, whatever they have on their mind.
Okay.
So again, thank you very much, and stay tuned for discussion.